Matrix collects analytical results. Here is a running example. Premature labor history significantly increases the risk of health outcomes in subsequent pregnancies, making it as a key factor for medical attention. Directed acyclic graph is increasingly used in medical research to visually present causal knowledge and assumptions between variables. Once one can manage rules for translating causal knowledge and assumptions into a DAG, and reading off expected statistical associations in a DAG, it can facilitate several tasks, such as choosing regression covariates to be adjusted for, understanding selection bias and information bias. Using DAG makes it easier to recognize and avoid mistakes in several analytical decisions. If you are interested in DAG, a book, An Introduction to Directed Acyclic Graph for Health Researchers thoroughly introduces DAG from the scratch. You can find the book in Amazon. You can also watch a short video about the book. You can find the links below. In this running example, DAG shows we estimate the causal association between premature labor history and the risk of low birth weight in subsequent pregnancies. Logistic regression will be used to estimate odds ratio. Logistic regression. This is the output after running logistic regression. Odds ratios are in the red box and the 95% confidence interval are in the blue box. This video does not focus on the topic itself and does not focus on how to interpret the odds ratios and 95% confidence interval. Rather, this video focuses on how to export the odds ratios and 95% confidence interval to an Excel table. Therefore, we skip interpretation. Store results in a matrix. In Stata, not just logistic regression, almost any regression, Stata stores all results in a matrix named as R table. This slide shows how to find the matrix R table. The red circles display the working flow. Number 1 is to run logistic regression. Number 2 is to list the matrix R table. As you can see, odds ratio are in the red box and the 95% confidence interval are in the blue box. Analytical results organization in matrix. Tip and trick. Copy R table and name it as a capital letter. The red circles display the working flow. Number 1 is to run logistic regression. Number 2 is to copy R table and name it as a capital letter O. Number 3 is to list the matrix O. Matrix O has the same information as matrix R table, but it is much easier and quicker to write O instead of writing R table every time. As you can see, matrix O has 9 rows and 4 columns. Therefore, matrix O in this running example is a 9x4 matrix. Again, odds ratio are in the red box and the 95% interval are in the blue box. Submatrix extraction. To collect odds ratio, we extract the first row, second and third columns of matrix O. We write O square bracket 1, 2 followed by 2 points and 3 close square bracket. To collect 95% confidence interval, we extract 5 and 6 rows, second and third columns of matrix O. We write O square bracket 5 followed by 2 points, 6, 2 followed by 2 points, 3 close square bracket. Matrix operation. Row join Put the odds ratio and the 95% confidence interval together. We simply write T1 backslash T2. Matrix transpose. Matrix transpose. Matrix transpose is to flip a matrix, turn rows into columns and columns to rows. Notation for matrix transpose is a superscription of prime symbol, such as T prime symbol. If we write T prime symbol, the matrix T will be transposed. As you can see, T is a 3 by 2 matrix, R is a 2 by 3 matrix. A matrix with the analytical results. After the above process, we have collected all the analytical results in the matrix R. R is a 2 by 3 matrix. Put a matrix with analytical results to Excel table. Suppose we have prepared a table in Excel that presents the analytical results. Text inside the red box is the name of an Excel file. Text inside the orange box is the name of a sheet in the Excel file. Excel uses numbers to define horizontal rows and use capital letters to define vertical columns. We wish to export a matrix R to these Excel tables. The empty cell in green, C7, is the starting cell that analytical results should be located. We start with the write cd command, which means change directory. You should put a directory path where Excel file is located inside the citation mark. Text in blue are Stata commands. Stata command put Excel set, then Excel files, comma, sheet, name of the sheet, and modify. Stata command put Excel, C7 equal to mat parentheses R. After running the above 3 command lines, matrix R with analytical results has been exported to Excel tables. Stata commands export analytical results to Excel table. It starts with analytical regression. Here, we give example of logistic regression, but it can be almost any regression. The 7 Stata command line fill out a prepared analytical table in Excel. Number 1, mat O is copy results from R table. Number 2, select the coefficients from matrix O. Number 3, select a 95% confidence interval from matrix O. Number 4, the coefficients and the 95% confidence interval will be joined together. Number 5, turn rows into column and column into rows. Number 6, inform Stata about which Excel file and which sheet should be used. The last one uses the matrix, fill out the table. You should modify the following parts: the red 2 followed by 2 points, and 3 specify columns in matrix O or R table. You should identify columns after running your own regression. Logistic specify Excel file, PTL3 specify sheet in the Excel file. You should find your own Excel file and your own sheet name. C7 specify a starting point in the table. You should identify your own starting cell. Downloadable do file. Go to the home page under Reproducible Data Analysis Data. You can find a do file export analytical result do. You can download the do file and try it out yourself. This end of this video. See you next one.